Hello everybody. So today we're going to look at fractions. Namely, we're going to discuss the parts and ways that we can represent fractions, and then we'll tie this all together to look at equivalent fractions. But let's begin with just what is a fraction? It's a quantity expressed over it's a part over a whole. So usually this is represented as the top part tells us a part, and the bottom gives us the whole quantity. Now, um, mathematically, the part is defined as the numerator, and the whole is defined as the denominator. So, an example of this, one basic fraction that I'm sure you guys are all familiar with is maybe the fraction 1/2. And we're looking where 1 is the part, and then 2 is the whole quantity that we're. So we can represent this using a rectangle where we shade one portion, and then one portion is shaded, which represents the numerator, and then the total quantity, we have two rectangles. This rectangle is split into two portions, so that would be demonstrated using the denominator. Now, to build up from this, let's say we were to break this fraction even more, or break this rectangle that we started with, and broke it up into smaller but equal quantities. And what we want to do is, the reason why we're doing this is in order to establish an equivalent fraction. So for something to be equivalent, that means that they are equal, essentially. They describe the same thing. So imagine, instead of having this rectangle broken up into two equal portions, how about I break it up into 4 equal portions now? Yet still, the left hand side that I have shaded above will remain shaded. But now we have 2 parts that are shaded over a total of 4 parts. Now we have, from here it follows that 1/2 is equivalent to 2/4. Now we can extend this idea with any kind of fractions. So for example, we can say, we can look to see what fraction is equivalent to 3/7. And we want a fraction that is equivalent to 3/7, and let's say we want a remainder of, a denominator that has 14 on the bottom. Now, if I wanted to make this value on the left, the denominator, look like the value to the right, I would have to multiply the denominator by 2 to get this guy to look like that guy. So, because this is equivalent, because we want to establish an equivalence, whatever I do to one number, I have to do to another. So if I wanted to find out this number right here, I would multiply the top by 2. As a result, we get 3 times 2, and the value is 6. So then an equivalent fraction for 3/7 would be 6/14. And another example would be, say we have a fraction of 5/8. And we want an equivalent fraction where the numerator is 15, and then we want to figure out what would the denominator be. So yet again, in order to transform 5 into 15, we would have to multiply it by 3. So because we want to establish an equivalency, whatever we do to one value of the fraction, we must do it to the next value. So we'll multiply the bottom by 3. 8 times 3 is equal to 24. So then an equivalent fraction is 15 over 24. Now, why does this work? Well, let's look at it again. Let's look back at the first example where we did 3 over 7. And then I multiplied it by 2. I multiplied the numerator by 2. And then I multiplied the bottom by 2. And essentially, this forms a large one. And this is what I was taught. So the idea is that you're just multiplying it by a fraction, by a whole quantity. That's another way of representing the quantity 1. Because 2 over 2, that means that if you were to look at that as a rectangle, that's basically a rectangle that's broken up into two portions where both portions are shaded. And that would signify a rectangle that is completely shaded. So by doing this multiplication to both the numerator and the denominator, that leaves our fraction unchanged, and therefore we establish an equivalent fraction. Now, this is a really important concept when dealing with arithmetic, fraction arithmetic, because what we'll see in the future is that we are allowed to add fractions that have a common denominator, but not allowed to add fractions that do not share a common denominator. So therefore, we must use this idea of equivalency in order to establish the common denominator. Now, we will look into this concept in depth in one of the next videos.